Today's note 6.3 Measures of Central Tendency. The objective: students will be able to find the mean, median, and mode and determine the advantages and disadvantages of each. It is very useful to have one number that represents the whole data, and so it makes sense that this measures the center of the data set. A measure of central tendency is a measure that tells us where the middle of a data set lies. The three most common measures of central tendency are the mode, the mean, and the median. The mode is the value that occurs most often. So I think of MO, mode, MO, most often. There can be more than one mode if two or more values occur most often. If no number occurs more than once in the set, then there is no mode. If there are exactly two modes, we call it bimodal. Okay, if there are two modes, exactly two. All right, so in example 1, which number occurs more often? It's the number 7. Because 7 occurs 3 times. A group of students were surveyed to find out how many hats each of them owned. The data is displayed in the following frequency table. Find the modal number of hats. So look at that table. Which has the highest number of hats? The mode is 1 hat. Notice it's not 7, okay? It's not 7. The modal is how many hats, okay? Frequency is the number of hats. Note, when asked for the mode of group data, you should state the group that has the highest frequency. This is called the modal class. You cannot tell which value within that group has the highest mode. In example 3, this table shows the ages of students who exercise in the gym after school. Find the modal age. Well, you're going to look at the highest frequency. So the modal age is 16 is less than y less than or equal to 17. Because that interval has the greatest frequency. All right, the mean. The mean is the average set of data and is the most common measure on central tendency. The mean, you compute it by adding up the data values and dividing by the number of data values. Mathematically, we write this as x bar, okay, that looks like an x with a little bar above it, equals the sum of your x values over n, where the summation of x is the sum of the data values and n is the number of data values in your population. Unlike the mode, the mean is often not a member of the raw data itself. So how do you find the mean that's in a frequency table? Because I think you can add them up and divide by. We don't need to do a basic mean problem, but we're ready to do an IB calculus level 1. So if I have, so suppose you want to find the mean of a class's IB grades. So on the IB, you're going to get a grade of 1 to 7 if you're an IB diploma student. So what we're going to do is it's called F sub X. And what you do is you take the grade times the frequency. So that's 14, 24, 40, 12, 6, 2, and 0. The sum of your frequencies, okay, so you're going to add up your frequencies. So you're going to add the 2 plus 4 plus 8 plus 3 plus 2 plus 1 plus 0. The frequency is 20. And the sum of F sub x is 98. Okay, so like there are 2 students who had a grade of 7. There are 4 students who had a grade of 6, and there are 8 students who had a grade of 5, and so on. So instead of writing 7 plus 7 plus 6 plus 6 plus 6 plus 6 plus 5, 5, 5, 5, 5, 5, then the mean is the sum of your frequencies. Oops, nope, sorry. I'm writing that backwards. The sum of fx over the sum of the frequencies. There we go. So it's 98 over 20. So that's 4.9. So notice there's no 4.9 in the table. This is what I meant by the mean is often not a member of the raw data itself. When data is given in grouped frequency table, you have to assume that the data is equally spread out in each of the classes and use the mid-interval value of each class as the representative for this class. Because of this assumption, you can only find an estimate of the mean because we're making an assumption. So this table shows the ages in years of 10 pet cats. So what we're going to do is we're going to find what's called the mid-value. The mid-value is halfway between, so that would be 1, 3, 5, and 7. Then we're going to do the frequency of the mid-value. So you're going to take 2 times 1 is 2, 4 times 3 is 12, 3 times 5 is 15, 1 times 7 is 7. So the mean, whoops, I forgot to add them up. So let's add up the frequencies. So we're going to take the sum of the frequencies. How many are there? There's 10. And then we're going to do the sum of f sub m. So go ahead and add those up for me. I got 36. So you'll take 36 over 10, which is 3.6, and that's in years. Sometimes you may be given an average of a group of data and asked to find the data value that is missing. So in this example, Will has scored 85, 93, 92, and 84 on the first 4 mathematics tests of the term. Find the score that Will must get on the last test to finish with an average of 90%. So I would do 85 plus 93 plus 92 plus 84 plus x. And there are 5 tests. So x is the score on the 5th test or final test. All right, go ahead and solve this. I got 354 plus x over 5 equals 90. Multiply by 5, and x is 96. So Will needs to score a 96 on the final test to finish with an average of 90%. All right, the median. The median is the middle value when the data are arranged in order from smallest to largest. Okay, it does have to be ordered. Then the mean, okay, if the number of values in the data set is even, then you're going to take the mean of the 2 middle numbers. So let's put these in the right order. So I'm going to go 1, 2, 4, 7, 9, 10, 11, 12, 16, 17, 18. I personally just count in 1, 2, 3, 4, 5, and then the 10 is in the middle. So if it's an odd number of data, then the median is the middle. If you'd have an even, then you'd take the 2 middle ones and take their average. All right, what will happen to the measures of central tendency if we add the same amount to all the data values or multiply each data by the same amount? So what if I give you 6, 7, 8, 10, 12, 14, 14, 15, 16, 20. So go ahead and find the mean, median, and mode. So I got 12.2, 13, and 14. So if you add 4 to each of these values, I didn't quite give you enough space, but go ahead and do that. If you add 4, then compute the mean, the median, and the mode. What's interesting is all 3 values, they increase by 4. Likewise, if I take each data value and multiply by 2, guess what happens? They all double. Okay, so here's the last thing here. Mode, the mode tells you the most frequently occurring value in a data set. The advantages, extreme values do not affect the mode. Disadvantages, it does not use all members of the data set. It's not necessarily unique, maybe more than one answer. When no values repeat in the data set, the mode is every value and is useless. When there is more than one mode, it is difficult to interpret and or compare. The mean. The mean is the sum of all data values divided by the number of values in the set. So the advantages, it's the most popular measure of average in fields such as business, engineering, and computer science. It uses all members of the data set. It is unique. A data set has only one mean. Useful when comparing sets of data. The disadvantages, it gets affected by extreme values, which we will talk about later. The median. The median describes the middle of a set of data. The advantages, extreme values do not affect the median as strongly as they do the mean. Useful when comparing sets of data. It is unique. A data set has only one median. As the median is the middle value, 50% of the data is either side of it. Disadvantages, does not take into account every value in the data set, and it's less use in further calculations. All right, that finishes for today.